So, very good evening, everyone, and welcome to the NPTEL's 11th live interactive session on the course Engineering Metrology. The course instructor for this course are Professor J. Ram Kumar and Professor Amandin Singh Oberoi, and I am an additional TA, Shubham Jaiswal. I am a research scholar in the Department of Material Science and Engineering at IIT Kanpur. So, in this live interactive session, we will be going to solve some samples problems related to your weekly content, which will in turn will help you to solve your weekly assignments. So, as this is the live interactive session, I hope for the interaction. Okay. Chandu, am I audible? Mr. Chandu, am I audible? Okay. So, in this live interactive session, we will solve some samples problems. So, before going to solve some samples problems, we will quickly recapitulate what we have covered in the last week content. So, last week we have started with the probability distribution. So, probability distribution in last week we have started. So, what is probability distribution? It is a function, table, or an equation that shows the relation between outcome of an event and its frequency of occurrence. Okay. So, it is nothing but a function, table, or equation that shows a relationship between outcome of an event and its frequency of occurrence. Okay. So this is about the probability distribution and probability density function. So after this point, we have seen we have listed what are the general types of distribution that we use. The first one we have seen is Poisson's distribution. Second one is binomial distribution. The third one is log normal distribution. Fourth one is rectangular, then triangular, and in the very last it's normal. So out of these six, the first two, that is Poisson's distribution and binomial distribution, are used for discrete data, and the remaining four are used for continuous data. Okay. So after this point, we have seen each and every distribution in detail. So first we begin with the Poisson's distribution. So what is Poisson's distribution? It is used to show the how many times an event is likely to occur over a specified period. That is, it talks about the time, that is the specified interval. Okay, so when we need to find the distribution or the probability in the specified time limit, then that time we use the Poisson's distribution. So it is used to show how many times an event is likely to occur over a specified period. So the probability density function for Poisson's distribution is given as P K events in an interval is equal to e to the power minus lambda to the power k divided by k factorial. So here the k is the event that for which we are finding the probability, and lambda is the event rate, or in simple word we call it as average number of event in an interval. Interval. Okay. So as it is the discrete function, so meaning that variable can take only specific values, like whole numbers only. So it is a discrete function, meaning that variable can take specific values like whole number 0, 1, 2, like, okay. And if we plot the Poisson's distribution for different lambda, so what we will get, okay, so let's say this is for lambda equal to 2. This is lambda equal to 4. Suppose this is for lambda equal to 10. So as we can see from this figure, as the lambda increases, it will be close to normal distribution. Okay. So after that, we have seen the binomial distribution. Binomial distribution. So what is binomial distribution? It can be the thought of simply the probability of success or failure, whether we will get a success or a failure. Can be thought as a simply the probability or success or failure. Okay, so the PDF, that is the probability to get exact case success, is given by equation P x equal to K P to the power K 1 minus P to the power n minus K, where P is equal to probability of success and 1 minus P is equal to no success. Okay, so this type of distribution, like a binomial distribution, are generally preferred in attributed kind of inspection, whether it is yes or no, whether it will go or no go, like this. So most applicable in attribute kind of inspection. So after binomial distribution, we have seen the log normal distribution. Log normal distribution. Okay. So log normal, it is the continuous probability distribution of a random variable in which logarithm is normally distributed. So it is the continuous. In which logarithm is normally distributed. So failure or durability projection or the event whose outcomes tends to be skewed towards the extreme of the distribution. That time we use log normal distribution. So like failure of durability projections events whose outcomes tend to be skewed towards extremity of the distribution. At on the one end, it will be the skewed one. Okay, so and the probability distribution function for the logarithmic distribution is given by equation 1 upon x sigma, that is standard deviation, divided by 2 pi into e to the power minus log of x minus mu whole bracket square divided by 2 sigma square. Sigma square is also known as the variance. Okay, so this is about the normal distribution. Okay, so after normal distribution, we have seen the rectangular distribution. So what is rectangular distribution? It is the distribution that describes an experiment when there is an arbitrary outcome that lies between the certain bounds. Like suppose if I have minimum value A and maximum value B, and if the outcome lies between these two, then that time we can simply use the rectangular distribution. So the distribution describes an experiment where there is an arbitrary outcome that lies between certain. So suppose here I have A, here I have B, and the outcome lies within these two bonds, then that distribution is rectangular distribution, and the probability density function is given as 1 upon B minus A when A is less and equal to 0. Okay, otherwise if it is less than A and greater than B, then the probability of that outcome is 0. So next we have seen the triangular distribution. Okay, generally we will try to overestimate in each time. Triangular distribution. So what is triangular distribution? It is a process in which our likely outcome falls between the our lower bound and upper bound with the pack, and it will be having some peak value or the mode, and when our population is sparse or the very less, when we have very less population, that time we can use triangular distribution. In which lower bound A and upper bound B with peak value or mode C. Okay. And the population is so. Suppose I am having one lower bound A and upper bound B, and my mode is suppose C. So if I draw this line, so I will get a triangle. So that's why the name is triangular distribution. So in this case, the probability density function, it depend upon the outcome in which range it lies. So we have 5 different PDFs for triangular distribution. So first one is 0 when x is less than a. Then we have 2x minus a divided by b minus a and c minus a. When this condition, when a is greater than or equal to x but less than c, and 2b minus x upon b minus a and c minus a. So this condition is means this will be the probability density function when c is less than x and x is less than or equal to b, and it is 0 when x is greater than b, and it is 2 upon b minus a when exactly x equal to c. So this is about the triangular distribution. So after this point, we have seen the normal distribution. And also known as Gaussian distribution. So normal distribution or Gaussian distribution. So in our day-to-day life, most of the physical properties that are continuous or regular in time, they generally fall in the normal distribution. So physical properties that are continuous or regular with variation due to random error. So in this type of distribution, most values, that is the cluster of values, will be in the middle of the range, and rest will be the taper of the curve, or and it will be the symmetrically towards either extreme ends. Okay, so most of the values will lie in the center of our range. Okay, So if we have suppose one range like 1 to 10, so the values in that range will most be likely to occur at the center. So in this case, mean is equal to mode is equal to median. So most values cluster in the middle of the range and rest taper off symmetrically towards either extreme end. Okay, and the probability density function is given by equation 1 upon sigma at under root 2 pi to the e to the power minus minus mu square divided by 2 sigma square. So it is the asymptomatic distribution. What do you mean by asymptomatic distribution? When the values tends towards the infinity. Okay, when the distance between the line and the curve approaches to 0, it tends towards the value of the variable tends towards the infinity. So it is curve. Okay, so if I draw a normal distribution, so it will be somewhat like this. Okay, so this is our normal distribution curve. Okay, so if I put our mu is equal to 0, that is mean equal to 0 and standard deviation equal to 1, so we can find the distribution or the area that it covers within that sigma limit or the standard deviation. So let me put plus sigma, minus sigma plus sigma minus 2 sigma plus 2 sigma minus 3 sigma plus 3 sigma. So in this normal distribution curve, so it covers 68.2% of values in the sigma limit, that is minus sigma and plus sigma. So it covers almost 68.2% value. Okay, and within the minus 2 and plus 2 sigma limit, it covers near about 95% of the. It is about 95%. And when we consider the plus 3 sigma limit and minus 3 sigma limit, so it covers almost 99.7% of values. Okay, and we can convert any type of distribution to the standard normal distribution if we just subtract it with the mean and divided it by the standard deviation. So the standard normal deviation given by equation Z equal to x minus mu divided by sigma. So Z is known as normal deviate, and x is random variable, mu is mean, and sigma is standard deviation. So if we just calculate the deviate, we can easily get the value of probability from the charts. Okay, the chart. So as this value will not going to be changed for any conditions, like that 68.2, 95, and 99.7. So we can easily produce the standard charts, and from the z value we can determine the distribution. Okay. So after normal distribution, we have covered skewness in normal distribution. And later that we have covered statistics for proportion. So what is proportion? Proportion is just nothing but a binomial count divided by n. So proportion is just a binomial count divided by n. Okay. So for binomial, if we consider for binomial distribution, the mu is nothing but np. Sigma square, that is variance, is np 1 minus p, and standard deviation is nothing but the square root of variance. So if we divide this binomial by n, we will get the proportion. That is the statistic. That is the statistic. That is the proportion for which we will be calculating the distribution. So for proportion, mu of proportion is p. Variance of proportion is p 1 minus p by n, and standard deviation of proportion, that is under root p 1 minus p by n. So after this, we have seen the chi-square. Okay, when we use the chi-square, when we does not know the mean, okay, when the mean is not given and we have the standard deviation, okay, at that time we use the chi-square distribution. Chi-square distribution. So when does we use chi-square distribution? When mean is not given, only standard deviation is given. Okay, that time. So what it does? It makes the estimate based upon the standard deviation of the sample. Okay. So it can make the estimate based upon the standard deviation of sample. That is, the chi-square is given by v sx square divided by sigma square. Okay, so here that v is nothing but the degree of freedom, and that is n minus 1, and sx square, it is the standard deviation of what? It is the standard deviation of sample. Don't get confused with the standard deviation of population. Okay. Standard deviation of sample and it is population standard deviation. Okay. And after at the end we have seen the data outlier detection. Okay. How to detect the whether data outliers or not. Okay. So this what we have covered in the our last week content. So now moving towards solving our problems. Here it comes. The first question is the Poisson distribution is highly skewed if the value of lambda is large. Is it true or false? What do you think, Mr. Chandu? Okay, let's see. So, in Poisson distribution, the PDF is given as P is equal to e to the power minus lambda to the power k and k factorial. Okay. So if we draw the plot for Poisson distribution with various lambda values, okay, with increasing lambda value, so we can see that so suppose this is for lambda is equal to 1. Let's consider this is the this is lambda equal to, let's say, this is for lambda equal to 10. Okay. So as we can see that the lambda is tending towards means lambda is increasing, the Poisson distribution is shifting towards the normal distribution. Okay, it will be close to the normal distribution. Okay, so it will be close to the normal distribution. So what is given is when the data is hello. Okay. So when the data is at the extreme ends of our distribution, so that is known as the skewness. Okay. So if we can see from this figure that when the lambda is equal to 1, the most of the data is near to our this axis. Okay, near to 0, and as our lambda is increasing, okay, it is moving to our right side. So, but it will not will be skewed as the lambda is increasing. Okay, as we can see here, it is moving. It will be close to the normal distribution. So in Poisson distribution, when lambda is increases, so it will be close to the normal distributions. But what they have said in Poisson distribution is highly skewed if the value of lambda is large. So which is totally incorrect. The correct answer will be the false. Is that clear, Mr. Chandu? So here comes question number 2. The sum of probability of failure and probability of success in binomial probability distribution is always 0, 0.5, 1, none of these. Yeah, Mr. Chandu, you are right. So let's say P is the probability of success. Okay. And 1 minus P will be the probability of no success. So when you add these two probability, that is 1 plus 2, you will get will be equal to total probability will be equal to 1. So the correct answer will be 1. So always remember the probability cannot be greater than 1. Okay. So this was just a simple question. Now moving towards our third question. Which of the following statement is about outliers is not true? Outliers are values very different from the rest of the data. Influential cases will always show up as outliers. Outliers have an outliers have an effect on the mean, or the outliers have an effect on the regression parameter. For your simplification, I will draw here one plot, and from that you can easily apply all these points and check which is not true. So this is the data. Now cross check this all these points with this graph and tell me the answer. Yeah, what do you think, Mr. Chandu? So the first option they have given is that the outliers are values very different from the rest of the data. Yeah, it's true because it's the definition of outlier. So any data which is different from the rest of the data, okay, means it is very different. Like here you can say here if we consider this data, it is increasing like this. Okay, so we will be able to have some correlation in that one. But this data, okay, this lies outside of from our rest of the data. So this is outlier. So that's true. The second one, it's true. So influential cases will always show up as outliers. It need not to be true. Okay, why? Sometimes that influential cases will be less. Okay, that time it will not show as an outlier. So it is false. So outliers have an effect on the mean. Yeah, it's true. Let's consider data 1, 2, 3, 4, 5 up to 10. So if I take the mean, it comes out to be 55. But if any outlier value will be there for like up to 10, 20. So it will have the different mean. Okay, so the mean is going to increase or decrease depending on the value of the outlier. So outliers have an effect on the mean, so it is true. So outliers have an effect on the regression parameter. It's true. If it is changing the mean, so also it is affecting our regression parameter. So it is also true. So they have asked which of the following statement about outlier is not true. So only the second option is not true. That is, influential cases will always show up as outliers. So now moving towards our fourth question. The skewness and kurtosis of the normal distributions are respectively 0 and 0, 0 and 1, 1 and 0, 1 and 1. What do you think, Mr. Chandu? So the skewness is given by SKP equal to x bar minus mod divided by standard deviation. So in case of normal distribution, the mean is equal to mod is equal to median. So the skewness will be 0. So here we can eliminate these two options. So now we have 0 and 0 and 0 and 1. Okay. So we have not discussed kurtosis in that much detail. So we will be discussing in the upcoming videos. Okay. So the in simple word, for the time being, the kurtosis is a measure of tailness of a distribution, or in simple word, with the peakness of the distribution, how much the peak is sharp, like that we can say. So suppose here if I draw okay, so here we have three different conditions. So what is the kurtosis? Is the measure of tailness of the distribution. Okay, how much big tail it has, or the how much highest peak it has. Okay, so when it comes to the normal distribution, so the kurtosis is 0. So this is positive kurtosis, this is 0, and this is negative. So this is for normal distribution curve. Okay. So this is about the kurtosis. So the correct option will be the first one. that is skewness is 0 and kurtosis is also 0. So the next question is, the dividing lines between the random and non-random deviation from the mean of the distribution are known as upper control limit, lower control limits to sigma limits. For your easy understanding, I will draw one figure. From that you can easily answer. So let's say this is my mean. And this is my deviation. This is mean and this is our deviations. Okay, let's say this is our deviations. Okay, now you can answer. Yeah, Mr. Chandu, let's see. So this is my mean. Okay, if I have any values, okay, or the deviation like this from the my mean value. So if we consider this line, okay, so what does it implies? It is the upper limit beyond which the process should not go. So it is what it is controlling. It is controlling upper control limit, and this is for the similarly this is on the negative side of the mean. So less than the mean. So this will be nothing but the lower control limit. And what they are saying, the dividing lines between random and non-random deviation from the mean of the distribution are known as, so this will be our control limit. So when we are considering normal distribution, in that case we will get the 2 sigma limit. But when the line divides the our random and non-random deviation from the mean line, then mean line of the distribution, then that is known as our control limit. So now moving towards our next question. The range of normal distribution is 0 to n, 0 to infinity, -1 to +1, or minus infinity to plus infinity. I will draw a curve for you. So from that also you can easily answer the question. Now answer. Okay, so let's see. So this is our normal distribution curve. As we have seen here, sigma minus sigma. So this value is continuously increasing. Okay, till when? Till this gap. Okay, this curve and this line, it tends to 0. Okay, when this line and this curve tends to 0, that means our the range will be our, when this will tends to 0, when our range will tends to minus infinity to plus infinity. So we just consider up to plus 3 sigma to minus 3 sigma. So it does not mean the normal distribution have a range from minus 3 sigma to plus 3 sigma. It has the range from minus infinity to plus infinity. So this will be minus infinity to plus infinity. But if we are only considering this much portion, okay, so if we are considering this much portion, okay, then then that time it will be from 0 to infinity. So this is the range of normal distribution. Now the next question. The probability distribution is a function or a table, or it can be an equation that shows the relation between the outcome factor, median or error of an event and its frequency of occurrence. What do you think, Mr. Chandu?
Outcome, sir.
In the very beginning, when we are recapitulating what we have seen in that recapitulating, that time only I have given you the definition. What is probability distribution? So it can be a function, or it can be a table, or it can be an equation that shows the relation between what will be our outcome of an event and how much times it is occurring. That is the frequency of occurrence. So the correct answer will be outcome. So now moving towards next question. Measures of the degree of thickness of a distributions are called. So suppose so this diagram I have already drawn in the question number 4. So now from that, take the reference of that question and try to solve this question.
Sir, first option.
Huh?
First option, kurtosis.
Okay. First option. So yeah. So when we need to measure the thickness, means how much peak it has, or the how much tail it has, how much long tail it has, or the how much sharp the peak is. Okay, so that we measure using the parameter known as kurtosis. Okay, so kurtosis can be positive, negative, or even 0. So in normal distribution, the kurtosis, it has some other name known as mesokurtic. Okay, so this was about the kurtosis. Now our next question is, a sampling distribution is the probability distribution of which one of the following? A sample statistic, a population parameter. Read the question carefully. In the question itself, the answer is given. So in sampling distribution or in the probability distribution. So in probability distribution, what we do, we calculate the probability for the given sample statistics by considering a population. So the correct answer will be a sample statistic. So now our next question will be chi-square test is used to find whether the standard deviation of the sample predicts the value of the standard deviation of population or not. What do you think, Mr. Chandu?
Sir, true.
So it's true. When does we use chi-square? When mean is not given and only we know the standard deviation. Like if you see the equation of chi-square, you can see. So these both are the standard deviation. Okay. One is the sample standard deviation, and another one is the population standard deviation. So in this equation, if you can see, the chi-square test is to find whether the standard deviation of the sample predicts the value of the standard deviation of population or not. So yeah, so we can use this one. So it is true. Now moving to our next question. Probability distribution shows the relation between the outcome of an event and slide is not moving actually. Okay. The probability distribution shows the relationship between the outcome of an event and its frequency of occurrence. Is it true or false?
True, sir.
Yeah, it's true. Because it shows the relation between the outcome and our event. So the next question, which of the following is a case of Poisson distribution? Number of cars arrived in 1 hour, number of defective produced in 1 day, both of these or none of these?
Sir, both of this.
Both of these. And why is it so? So let's see. Why is it so? When we consider the Poisson distribution, so it is used to show how many times an event is likely to occur over a specified period. Okay. So the word, focus on the word specified period. Okay. So it is talking about the interval. So it can be time interval. So in first case, we have 1 hour. So it is interval. Okay. So they have given our time interval or for a specific period or for a specific period of 1 hour. Similarly, in second case, they are talking about 1 day. Particularly for 1 day they are talking about. So in both these cases, the specified period is mentioned. Okay, so that is the condition of our Poisson distribution. So the correct option will be the both of these. Okay. So moving towards our last question. Which of the following distribution is applicable for the given situation? Describing the number of occurrences n for a particular outcome during n independent test where the probability of any outcome p is the same. So which distribution we use? So if we have n independent test and the probability of the any outcome is same, so that distribution is binomial distribution. So Mr. Chandu, you are correct. It's binomial distribution. So that's it for today. So we will wind up our session here, and if you have any doubt in these questions, you can ask now, or we can end our session here.
Thank you, sir.
Okay. So, thank you, everyone. So, as this is the just